Okay, where do you guys want me to start?
48.
Number 48? Okay, yeah, word problem, so nobody knows what to do. Okay, number 48. An earthquake of magnitude 7.7 occurred in 2001 in wherever that is. It was about 4,900 times as strong as the greatest earthquake ever to hit Pennsylvania. What is the magnitude of the Pennsylvania earthquake? And they would like us to refer to the Richter scale on page 453, yes. What's the question? Oh, thank you. Thanks.
Pop that.
Okay. What do you see from the Richter scale on page 453? All right, so if you had taken the time to look and see the Richter scale on page 453, what you would have seen is that for every time it goes up 1 on the Richter scale, the earthquake magnitude is 30 times as great, okay? So if this earthquake was 4,900 times as large as the one in Pennsylvania, we need to figure out 30 to the what power equals 4,900. How many more jumps on the Richter scale is this earthquake than the one in Pennsylvania? Does that kind of make sense?
I'm guessing.
0.4,
Yeah,
because this number is less than 30, so 30 to the 0.4, not feeling it.
No, I'm going to go with
Okay.
it's,
All right, how about, wait, time out.
3.6.
We have had this discussion before.
We did.
do not need to guess and check for these things.
Oh, it's
As
fast.
I have a variable in the exponent, what do I need to do in order to solve this?
What do you find it?
Thank you. It's a little frightening that like only one person is telling me that. I need to log both sides. Okay, so if I log both sides, what can I do with the variable? Move it into the front, so that means x times the log of 30 equals the log of 4,900.
I said 0.5 less.
Oh, 0.5 less, gotcha. Okay, what?
Dividing side by log.
Good, dividing side by log of 30. Does anyone have that on their calculator?
Jake says 2.6.
Say again? 2.498. Okay. All right. So that means that this earthquake that hit Pennsylvania on the Richter scale would be 2.498 less than this one on the Richter scale. So how do we figure out what the Pennsylvania earthquake measured?
I think you might need to subtract that
So I'm going to go 7.7 minus 2.498, and they're going to give us about 5.2. Okay? So about 5.2 is what that one would have measured. Yeah?
On the 2.498, could you round up or?
Yeah, you could round that up. Since this is only to 1 decimal, you could round that up to 2.5.
Because it says about, right?
Right, about 5.2. Okay? All right, Alex? We can do number 78. Is that the last one? Okay, nice job, Alex. Do your homework finally.
Yeah, can we get all the emails?
All right, use the properties of exponential and logarithmic functions to solve each system. Check your answers. So this time, instead of just one equation that you are trying to solve, they're giving you 2 equations at the same time because you have 2 variables. Okay? So we're going to write out the 2 equations using our properties of logs, and then we're going to use our good old-fashioned algebra skills to solve that system of equations. So what is the base of this function right here? What is the base of it? What? 10. Okay? So that means I can start by rewriting that as 10 to the to the first power. It's this base number to this power equals this right here. So 10 to the first equals 2x minus y.
So there's always
Okay.
a 10.
If there's no number down here now, Tony was asking about what problem was that? Number 69. They had a base 8 there. Okay, so if there is a specific number written there, then that's what you use as the base. But if there is none, then it's always going to be 10. Yes. Next. then you need to use x. So it would be, then your variable would be over here.
So it's 10.
Right, it would be x to the first power equals this.
10 to the first power.
10 to the first power equals 2x minus y, and then 10 to the first power, of course, is just 10, so I don't really need that exponent, okay? Now this is a little bit trickier because I have a log on both sides. What can I do, first of all, with this? What can I do with the 3 that's in front? What's that?
Exponent.
Huh? Good, thank you, Ben. Make it an exponent. So I can rewrite this as log of x plus y equals the log of 2 to the third, okay? Because when you're multiplying, one of our properties of logs, property number 3, is that that becomes an exponent, okay? What is 2 to the third? 8. So this is really going to be the log of 8. Okay? All right, now you got a log on both sides, so there's a couple different options that we could do with this. What would you like to try? What's that? You want to get them on the same side so we can combine them? Okay,
Yeah.
so if I subtract log of 8 from both sides, then these will cancel. So that leaves me with log of x plus y minus log of 8 equals, what do I have now over here? It's going to in a second, yeah. What do I have on the right-hand side? 0, good. Okay, now Reed says subtraction in the world of logs is the same as division. So I can rewrite as a single log, log of x plus y over 8 equals 0. And now that I have that reduced to a single log, what can I do? Nothing. Problem is over. No?
It looks like now you could do
What did I do with this one right here?
Do the 10 thing.
Yeah, do the 10 thing because this is base 10. So I'm going to go this base number to this power. What's 10 to the 0? 1 equals this stuff right here. So 1 equals x plus y over 8. And so I don't really care for that 8 there in the fraction. How can I get rid of that? Multiply. Okay, so my two equations that I need to solve now as a system are 10 equals 2x minus y and 8 equals x plus y. So that is set up to do something really easy and happy.
Y by itself.
You want to solve for y? I do not. What's the easier thing that I can do one step to solve it? He wanted to do substitution, which is fine. He was going to solve both of them for y and set them equal to each other. We could do that. What's that, Cameron? Yeah, add them together, and if I do that, what happens to the y's? They will cancel. So 10 plus 8 is 18, 2x plus x is 3x, and the y's cancel, so that means x equals 6. And then if I know that x plus y equals 10, that means y must equal 4. Because 6 plus 4, I said 10, I meant 8, sorry. X plus y equals 8. So if x is 6, y is 2. Yeah, trying to make sure you're paying attention. Okay, so Alex, good question. That's a very challenging problem to do a system of equations with logs. Okay. This one from this equation right here. Yeah, for the very beginning. I know it was like 10 minutes ago. 60?
No, 66.
How about 60 and then we can go get 66?
Nice. Perfect.
Okay, it says the graphs of y equals 2 to the 3x and y equals 3 to the x plus 1 intersect at approximately that point. What is the solution of 2 to the 3x equals 3 to the x plus 1? What variable would we be trying to solve for in this problem?
Probably x.
X. Which one of these two things is the x? The first one, and so that means the solution to that system would be x equals, yeah, 1.1201. Where the graphs intersect is where the graphs intersect is the solution to the equation. Okay, James? Yes, you may. Did somebody say 66?
Yes, I did.
63? Sorry.
63 and then Poppy, why didn't you know the beginning? Good job, Alex.
Why do you need all these evens?
All right. Hey, guys. Gentlemen. Okay. 63. The noise level inside a convertible driving along the freeway with its top up is 70 decibels. With the top down, the noise level is 95 decibels. Find the intensity of the sound with the top up and with the top down. Okay, so do you remember that formula by any chance?
For which one?
For decibels.
It has a W in it.
You do though.
In the acoustics, right above.
Do you remember that one? Oh, it does? Oh, okay.
You know.
So we used this problem before to find the guys that were doing the construction work and to see if they were in violation of the code or not. Remember? It is 10 times the log of the intensity of the sound divided by I sub 0. And they tell us that I sub 0 is the sound of a whisper, which is 10 to the negative 12. Okay? So we're going to do this twice. Once for the 70 decibel sound and once for the 95 decibel sound. Okay? Are you ready?
Right.
Okay, good. Thanks, Oscar, for a little enthusiasm. All right, so 70 equals 10 log I over 10 to the negative 12. And I is what we're trying to find. What do you want to do first?
We're going to want to do,
Not yet.
throw it away.
I want to divide each side by 10.
Good. Let's divide each side by 10. So these 10s cancel. So 70 divided by 10 is 7 equals log of the intensity of the sound divided by 10 to the negative 2. So now that I have that down to a single log, what can I do with it?
And use the 10 deal.
I can use the 10 deal. This is a base 10.
Yep.
So I can go 10, this number here, to this power, to the 7th power, equals I over 10 to the negative 12. Okay? And then solving that for I is very, very simple. What do? Multiply by 10 to the negative 12. And what would 10 to the 7th times 10 to the negative 12 be? What do you do to the exponents? Good. Add the exponent. So the intensity of sound with the top up would be 10 to the negative 5th. And you know what, Reed? It turns out that is watts per meter squared. Yeah, strange. You have to talk to Mr. Weber about that. That's measured in watts per meter squared.
It says 1E negative 5.
Yeah, that's what this is, right? 10 to the negative 5th. That's the e to the negative 5 shorthand for that. All right, so now we're going to do the same thing, but we're going to set it equal to 95 this time. So 95 equals 10 log of I over 10 to the negative 12. Same as before, what do I do first?
Divide by 10.
Divide by 10. So 9.5 equals the log of I over 10 to the negative 12. And then 10 to the 9.5 equals, no, the log is gone when we do this exponent thing. Yep, I over 10 to the negative 12, okay? And then to solve this for I, I'm going to multiply, which is going to force me to add the exponents, and so I get 10 to the negative 2.5. Say that again. You could take this and bring it up here since it's a negative exponent, but then it would be I times 10 to the 12th. And you'd end up doing the same thing because then you would divide both sides by 10 to the 12th. And when you divide, you subtract the exponents. And 9.5 minus 12 is negative 2.5. So you can do it that way, you get the same
But
answer.
how do you get?
I added these exponents when I cross multiplied. So 9.5 plus negative 12. Okay, that was only the answer to part A though. B, by what percentage does leaving the top up reduce the intensity of the sound?
Find if it does or different.
50%, yeah. 10 to the negative 2.5 divided by 10 to the negative 5 is going to come out to be 50% or 0.5. All right? Okay, 66 and then turn them in.
Wait, can I get 42?
Okay, hold on. That was a fail. Sorry, Cameron. That doesn't work out that way.
B is 50%?
No, it does not work out that way, sorry.
Okay.
So we're going to want to, we reduced the sound to 10 to the negative 2.5, and it was originally 10 to the negative 5, right? Oops, sorry, I need the smaller number on top. So it should be 10 to the negative 5th, divided by 10 to the negative 2.5. So what do you do when you're dividing those with the exponents? Subtract them. So negative 5, negative 5 minus negative 2.5 is what? 10 to the, I'm subtracting a negative, so I'm really adding.
7.5.
So it'd be 10 to the negative 2.5. So now we need to do that on our calculator. What's 10 to the negative 2.5?
0.00316.
Point what?
0.00316.
Okay. So less than 1% it would reduce it by? What is
So like 0.3%.
Yeah. All right, and then 66.
Yes.
Yes. All even.
And then we're going to turn these in.
Yes.
Okay, so before I can solve 66, what do I need to do?
Put the exponents in there.
What's that?
Bring like the two above the x.
Yeah, I'm going to take these things that are multiplication and turn that into exponents. So I'm going to rewrite this as log base 3 of 2 to the 4th minus log base 3 of x squared equals 1. Does that make sense? Took the numbers from in front and turned them into exponents.
Yeah.
And then, first of all, 2 to the 4th is what? 16. So I'm going to write that as 16. Well, what's subtraction the same as division? So I can rewrite this as log base 3 of 16 over x squared equals 1. Okay? And then this addresses the question that Alex asked earlier in class. He said, is it always going to be a 10? No. Now we have a 3 here. Okay? So it's going to be 3 to the first power equals 16 over x squared. Yeah, this number to this power equals this stuff here. All right, so how do you want to solve that? Multiply by x squared. So I'm going to basically cross multiply. Think of that as being 3 over 1. So that's going to be 3x squared equals 16. And then divide by 3. So x squared equals 16 over 3. And then square root it. So I need to know what the square root of 16 divided by 3 is, and that comes out to be about 2.3094. 3094, because I want to the nearest 10,000. Okay? All right, will you guys pass those forward, please? Okay, so today we are going to wrap up Chapter 7 by getting into natural logs. Okay. Okay, logs we did, and they most typically had a base of what? 10. But you can make that base any number that you want, right?
Yeah.
Okay, so if you have a logarithmic function and you make the base e, remember our old friend e? Because 2.718 or whatever it is. Okay, since e comes up so much in like biology and banking and things like that, if you have a log with a base e, they gave that a special name, and that is the natural log of x. Okay, now you might kind of frown at that, like Megan just did and Miranda just did. Sorry, and go, if it's natural log, why is it ln? And I wondered that myself for many, many years until here in Montesano I had an exchange student, I don't know, maybe 6-8 years ago from Belgium. And he said it's because a French mathematician came up with this. And in French, it's logarithme naturel. Okay? Ooh, yeah, so a little French today. So it's logarithme naturel, but we just write it ln and pronounce it natural log. So on your gunculator, you would notice, hopefully, that there's a button with the log on it. And the inverse of that is 10 to the x, because log functions are most commonly base 10. And then when we were studying the natural number e before, that button goes with the ln button, okay? So log is base 10, natural log is base e. So the good news is, the stuff that we're going to do today is all exactly the same as what we were doing before, with one very small change. Now the base is e instead of 10, but all the other stuff is the same, okay? So if you take y equals e to the x and you want to find the inverse, you switch those around and make it e, and make it x equals e to the y, and then that gives you this function here, y equals the natural log of x, okay? This is the graph of natural log of x. This is the graph of its inverse, y equals e to the x, okay? Interesting fact about natural log of x, it is increasing forever, but it's increasing very, very slowly. If you made the scale on this equal to 1 inch this way and 1 inch that way, if you wanted this graph to go up 1 foot above the x-axis, you would have to go 3.5 miles to the right. That's how slowly this graph increases, but it does just a little tiny bit. Okay? What? No, I mean it's a math. We could prove it. We actually did this in calculus just the other day. We were doing this stuff, so you could actually figure that out. Okay? All right. So, like I said, exactly the same as the logs, except it's base e. So if I want to start and take this and rewrite it as a single natural log, what can I do with the 2? I got to bring it above the 15. So I'm going to rewrite it as natural log of 15 squared, or minus, sorry, gave away the answer there again, minus natural log of 75. What is 15 squared, by the way? 225, so I can rewrite that as the natural log of 225 minus the natural log of 75. And then just like when we did the other things, what is subtraction? It's division. So I can rewrite this as a single natural log. It would be the natural log of 225 divided by 75, which is the natural log of 3. Okay? So that can simplify all the way down to that. So same rules apply. Multiplication becomes an exponent, subtraction becomes division, and addition becomes multiplication. Logan?
Why don't we do like we did, like the log, the first log over divided by the second log, and like actually put it in the calculator.
Oh, that's when you're solving, using this to solve equations, which we will do in a minute. But this is just combining them into a single natural log, okay? We'll get there in a second, yeah. Okay, so let's rattle through a few more of these. Natural log of 7 plus 2 natural log of 5. What can I do with the 2? Make it an exponent. And you know 5 squared is 25, right? And then addition is the same as multiplication. So this would be the natural log of 7 times 25, which is the natural log of 175. James?
What on these natural logarithms or whatever you should call it? How is it possible to get 2 answers?
What do you mean?
Because on problem 2 it says that there's a possibility of getting got one answer and another answer.
Okay, well, can we get there when we go to problem 2? Right. Can you read the head?
Yeah.
Okay.
What log 7 times log 5?
Oh, okay, good question. So what you're saying, that's a really good question. What Matt is saying is when we are adding 2 logs, we can make it into the multiplication of 1 log, right? Or when we have the multiplication of 1 log, we can split it up and make it the addition. What if you are having the multiplication of 2 logs like that? Okay, really technically the only thing you could do with that is, since this is multiplication, you could make it into an exponent, right? but that'd be just weird.
Wait, how come this set up?
So usually you don't see this, but if you do, you would just leave it like that.
What would that be used
Okay.
for in real life when there's a multiplication?
Well, I don't know, the formula for the decibels had a 10 in front, so that would be a multiplication thing. Okay, sir? Luke?
Oh, how come that natural logs
Because remember, when you're multiplying by something, you can take that and put it as an exponent. Okay, now we're seeing. All right. Okay, what about B?
Easy.
Easy.
You bring the 3 and the 2 over, let's start it out.
Okay, so let's start out by bringing the 3 and the 2 in as exponents.
Be real.
And one thing that you need to be aware of, the mistake that you don't want to make, is this 2 is an exponent for both of these numbers right here, the 2 and the x, okay? So do not write it as just the natural log of 2x squared. It's the natural log of 2x squared. So what does 2x in parentheses squared simplify to be? 4x
X. And then the X
squared, okay? And then subtraction is the same as
Division.
division. So this would be the natural log of x cubed over 4x squared,
Whoa.
which simplifies to be what?
What?
What does natural log of x cubed over 4x squared simplify to be? What can I do with the x
X
cubed and x
over
squared?
4.
Yeah, x over 4. Because x cubed and x squared reduced to x. Okay. All right, and then for C, what do we got going there? Natural log of x, natural log of x cubed plus natural log of y squared plus natural log of 5 stays as the natural log of 5, and then addition becomes
Multiplication.
multiplication. So final answer, natural log of 5x cubed y squared. All right? Does that make sense? So same kind of properties that the log functions were for, okay? Okay, so we are running out of time a little bit here, so I'm sorry, James, we're going to have to put your question on hold, okay? I don't want to start solving equations yet. I want you guys to have a chance to practice again this, just the basic properties of natural log, all right? Okay, so give those a try. Those are some properties of logs, and then these right here are practicing that too.